So, hey everyone, I am Mihai, I'm a developer at Peso, and today I'll talk about reactive programming using RxSwift library. So let's take a look at what's this thing called reactive programming and how we can use it, why we need this, and yeah, let's go forward. And I will start with some definitions to give you a better idea what stands to the basic of reactive. And I will start with iterator versus observer patterns. So in short, they both describe sequences. In case of iterator, it allows you to get the data from a sequence with one item at a time and perform some action over this element. So you can think to an iterator as a producer. So you have some data, it gives the data to the consumer. So in this case, consumer is in control. He decides when he needs this data. So this is how it looks. We have the collection, we have our program or our code that needs to interact with this collection, and in between them we have the iterator. So we can ask the iterator for data, it gets the data from the collection and returns to the program. So a basic example will be loops. So we have the collection, we can make a well-known for loop and iterate through this collection, let's say print the elements. Actually this is syntax sugar, but what happens under the hood? This happens. We have the collection and we're making an iterator from the collection and we're asking the next element from this iterator. So in case it returns nil, it means that we finish iterating our collection. And the second one is observer. So it's pretty similar to iterator. You also have the data as a producer and the consumer. But the only difference between them is that the direction in which the data flows. So in this case, not the consumer is in control, but the producer. The producer decides when to give the data to consumer. And this is how it looks. We have some kind of subject. We can subscribe to this subject to be notified about that they changed. A good example is key value observing. So we have some object and some key path to some property that we want to observe. So we can add self-add observers. We can override the function observe value to be notified in this function with new value, and then we need to remove observer. So let's go forward and I'll try to define observable sequence. So I'll give you an example. Let's say we have a variable cursor position that observes the position of the cursor on the screen. And we're observing at a specific moment of time. So over time, this value will change and it will form a sequence with all of the values that were assigned to this variable. So this is in a sense an observable sequence. That's a value that changes in time. So this sequence can contain value or events like tabs or other gestures. So I hope I give you an idea what's observable sequence, and let's go forward and define reactive programming. So reactive is about managing observable sequences. It may sound difficult at this moment, but I'll give you some example and see that it's nothing difficult. So our sequence contains three types of events. The first one is next event. The second one is completed event. And it means that the sequence has finished to emit events and no more events will be emitted in this sequence. And the last one is error event, which means that something bad has happened and we need to handle that. And also no more events will be emitted in this sequence. Okay, that's cool, but why do we need this? It's simple. We just simplify our work a lot. So the benefit is more evident in more modern web application or mobile application that have highly interactive with UI events and data events. So 10 years ago, interacting with a web application was basically submitting a form to an API and performing rendering to the front end. So since then, applications have changed, and we have more real-time applications, like modifying a single value. We can perform automatically trigger a save into database or request to a backend and so forth. So we have like application with highly interactive experience to the user. So we need tools to properly handle that, and reactive programming is the answer. Next, I will give you some example of situation when we can use reactive programming in our work as iOS developers. And the first one is, of course, delegate. Okay, delegate is a cool pattern, but it gets really tiring. It's a lot of boilerplate code, like creating a protocol, creating a variable, setting the delegate, implementing the protocol. So this repetition can often make you forget things like setting the delegate or take care of retain cycles. So instead of have a lot of function implementation, we can usually just use Reactive extension and subscribe to events. So we can just perform the events in the block that will pass into this the subscribe function. And another example is KVO, or key value observing. So you're probably familiar with this runtime crash, that some instance was delegated while there are some observers that subscribe to it. So instead of using KVO, we can just use Reactive extension to subscribe to some properties and also perform some action in the subscribe next closure. So you don't have to take care of removing observer because RxSwift does it by himself. And of course, notifications. So without Reactive extension, you need to define a notification name to create the selectors for them, removing observer, and so on. So with Rx, you don't need this. You just create a sequence and react to received events when a notification is fired. Okay, next I'll give you some basic examples of operators that Rx offers to us. And I will start with creating observable sequences. And the first operator is just. It's the simplest one that creates just a sequence with one value. So how it looks, we have observable of strings. We use just operator and say that it will emit a next event with the string hello codeway. So we can subscribe, we can print the events, and then on complete we can print them down. And that's the result. Another operator is repeat. So as we figured out, this operator repeats infinitely a given value. So this is good, but what if we need to create a custom observable, let's say for a custom API call? For this, there is create operator. So here is an example. We're creating a URL session task, so we're firing a request to API. So in response closure, we can check for error. If there is error, we can push a error event into the sequence, or we can convert it to string and push a next event into the sequence, and then complete it because there are no more data. So we're firing the request, then we're subscribing and printing the result. That's all you need to do to create a sequence. Okay, we know how we create them, then let's take a look at how we can transform them. And I will start with map operator. It's pretty similar to map function from Swift. So it's very simple, it's a powerful operator. So it works similar to Swift, but here we're not transforming values, but sequences. So here how it looks. We have a sequence that emits ints. So we can apply map operator over the sequence, and it will create another sequence that will contains the values that are transformed, let's say multiplied by 10. This is how it looks in code. So we're creating a sequence that emits some integers, then we apply map on this sequence and we're printing them. So we have 10 and 20. Okay, let's take a look how we can filter events. So there is filter operator. So we can apply filter over a sequence and skip some events by a condition. Let's say that the events that are bigger than 10. So yeah, this is how it looks in code. Let's say we have a sequence with some phones and we want to give just the iPhones. So we just give the condition that I want to give the iPhones and subscribe and print them. This is how it looks. Okay, let's go forward and take a look at the bounce. So it's an easy operator, but a very useful one. This is what it does. The bounce just skips the elements that are very close one to each other. So in this example, I'm saying that I want to skip the elements that were fired less than 2 seconds before previous. So if an element will be emitted after 1 second, it will be skipped. If after 2 or more seconds, then it will be emitted. Combining. These operators can be very useful when you have to work simultaneously with more than one observable. So we can take multiple sequences, combine them, and in the result there will be one sequence you will work with. And the example is merge operator. So what does merge? Merge just take the elements from multiple observables and put them into a new one. This is how it looks. We have two observables. We can merge them, and we'll have one sequence that will get them both elements from both sequences. That's how it looks in code. We have two sequences, that one emits beer, second one emits pizza, and we can merge them, and you have a sequence that emits beer and pizza. Okay, that looks nice. Then let's take a look at a real-life example for our iOS development. Let's say we have a struct speaker that contains first name and last name and the computed variable full name. And we have a list of speakers. So we have a model with all the speakers. So what we want to do, we have a table view and a search bar. So when I'm tapping something in the search bar, I want to filter all the speakers and bind them to table view. And also when I'm tapping on a cell, I want an error to say that, okay, this speaker is awesome. So how we can do this in non-reactive way? First of all, we need our view model. And we need a variable that will contain all found speakers. Okay, what we're doing is we're setting the delegates and the data sources. And we need to implement them. Implementing the table view data source. So we're returning number of rows in table view. We need to configure the cell. We're creating a cell, setting the label, and returning this. And then we need to implement table view delegate. So we have a function speaker selected that will show an alert, and I'm just calling this function from this select row. Okay, another delegate is search bar should change text and range. So this function will be called each time when we tapping something in the search bar. So what it does, the first statement, it means that every time when returning from this function, I want to table view reload data to be called, so our table view will be up to date. Then I'm checking for nil for the text, and if there is no text, I'm just removing all from table view. Then I'm creating a new query, I'm checking if it's empty, and then I'm filtering the speakers. So I have a model speakers filter, and if full name contains new query, then I'm assigning this to found speakers, and I'm reloading table view. Okay, this works fine, but that's a lot of code. So all this code is separated into different delegates, data sources, so it's easy to get confused. Now let's take a look how we can implement that in reactive way. And I will start with an extension of a speaker view model that with a function that takes a query and return on an observable of speakers. So I can just check for nil. If it's nil, I'm returning an observable sequence with just operator. Then I'm filtering the speakers and returning the sequence. And in our review did load function, we are using reactive extensions. So there are extensions on UI search bar and on UI table view. We can work, it's free to use in our library. So we can access reactive extension over Rx property, and we can access text. So it's a sequence, so every time a new text will be changed, then this code will be executed. So what we're doing, we're using plot map operator and given a function, say the search function from our view model, and this, if you remember, the search function returns on observables of speakers. So we can give that observable to table view. So we're using bind to operator, and we'll give that I want to bind these elements into the cells with identifier speaker cell. And here we give a closure that configure this cell. And that's all. This code will search by query, will bind to UI and reload UI. That's only 5 lines of code instead of 4 delegates in data source. And then we can handle cell selection with model selected operator. We can say that when we're typing a cell, I want to call the function speaker selected. If you remember, this function is from previous example that says that alert. And that's all you need to do. Okay, what are the benefits? So by using RxSwift, our code will be first composable, because observables are intended for composing flows and streams of asynchronous data. We already seen how we can compose more sequences into one by using combining operators like merge. There are more operators like zip, combine latest, concat, and a lot of more. And the beauty here is that we don't have nested blocks with asynchronous behavior. Things happens linear and you never get confused. Reusable, because we don't have repeating implementation and a lot of boilerplate code. Declarative, because definitions are immutable and only data changes. Less stateful, because we're modeling application as unidirectional data flows, behaving like big pure functions. Flexible, because observables support not just emitting a single scalar value, but also a sequence of values or even infinite streams. So yeah, this is the GitHub repo for RxSwift. You can go and find like all the operators and the documentation. Also, I would recommend to go to Marble's website. There is a lot of interactive diagrams that you can see how all the operators work and when you need to use them.